Hi. So this is another question 6511. Assuming that cells can convert 2/3 of the substrate carbon to glucose to biomass. So your substrate, like I said, is the reactant, is your glucose here, and your biomass is the product here, the major product per se. Now you've been given the equations to be worked with, and you're asked to calculate the stoichiometric coefficient for the glucose consumption. I'm going to deal with the very first statement stated here. It said 2/3 of the substrate carbon. Now, the substrate carbon here is glucose having C6H12O6. So, 2/3 of 6. The substrate carbon having 6 as the number of moles to give biomass. Now, if I'm saying 2/3 of the substrate carbon, definitely and obviously, they are saying that this is equals to the biomass carbon. And the biomass carbon in this case is 4.4 beta 3. So from here, this becomes 2. So I have 4 is equals to 4.4 beta 3. And you can get your beta 3 to be equals to 4/4.4. Alright, now this is settled. You can use a calculator to get it in decimal. And now, to calculate the stoichiometric coefficient, we are going to be, like we've been taught in chemistry, we are going to be taking each of the elements one after the other, and we're going to be balancing them out on both sides. Now, what do I mean? Okay, for carbon, I have 6 carbon equals to, that's on the reactant side, 4.4 B3, okay, plus beta 4. Those are the only two places you have carbon on the product side. Now carbon is settled. Let's move on to the next element. Let's pick hydrogen. Now for hydrogen, I have 12 plus 12 here, and I have 3 beta 2 is equals to 7.3 beta 3 plus 2 beta 5. Okay? Now hydrogen is settled. I'm going to move on to the next element, which is oxygen. Now for the oxygen, I have 6 plus 2 beta 1 being equals to, I have 1.2 beta 3 plus 2 beta 4 plus beta 5. I see oxygen is quite on everything and on every side. Okay, moving on. I'm moving on to nitrogen now. Now for nitrogen, I have beta 2 is equals to 1.86 beta 3. Those are the only two places we have nitrogen. Now, do not forget that we got beta 3 earlier from the relationship they gave us. So if you have beta 3, let's move on to nitrogen. Now, given beta 3, that means I can easily calculate beta 2. So your beta 2 will be equals to 1.86 times 4/4.4. Get your answer in decimals. Now after getting beta 2, let's look at the next one that is very easy to calculate. Now from here, I have beta 3 and I just need beta 4. So I think that's quite direct enough. I have 6 equals to 4.4 into bracket. Beta 3 is 4/4.4. 4.4, sorry. Plus beta 4. Okay? So this becomes, if 4.4 should carry 4.4, cancel out or something. 6 minus 4 will give me beta 4. So telling you that beta 4 is equals to 2. Now that's settled. And I'm going to move on to the next one. Okay, I think we can pick hydrogen now. We have beta 2, we have beta 3, so we just need beta 5. So I can move on to hydrogen. Now for the hydrogen, I have it that 12 plus 3 into bracket beta 2. You know your beta 2 is 1.86 times 4/4.4. It would be very nice if you could just calculate this in decimal points, but as long as you understand the concept. So I have 4.3 into bracket 4/4.4. Like I said, it's best to leave this in decimal points. I'm just doing this for better understanding. It's way much better to leave your answers in decimals form. So plus 2 beta 5. Okay, so we can see that the only thing needed here is 2 beta 5. So get your 2 beta 5 being equals to 12 plus 3 into bracket 1.86 times 4 over 4.4 minus 7.3 into bracket 4 over 4.4. Please pardon my writing. From here now, you can easily get the value of beta 5. Just divide both sides by 2. That's all. You can get beta 5. We can see that we still have one more element left. That's oxygen. Yes. Now for the oxygen, I need beta 1. Now you already have beta 3, you have beta 4, you have beta 5. So just get the value of beta 1. That's all. So from oxygen, just going to state that here. From oxygen, get beta 1. Okay? Get beta 1. So that's all. As easy as that. So from there you have your stoichiometric coefficient. Now the next one is calculate the yield of biomass per substrate. Now the yield, the standard formula for yield of biomass per substrate is mass of biomass, alright, per mass of substrate. In one of the videos I explained that yield is how much of the biomass you were able to get from the substrate. It's more like a relationship. If your yield was 0.5, that means in every 0.5 grams of biomass, I used up 1 gram of the substrate. It's more like a relationship, and you can call it product over reactant because the biomass is the product, the substrate is a reactant. Okay, now that's settled, and then let's go back to the question. If I have my biomass to be this, I can easily get the molar mass of the biomass. We're not given the mass, mind you, but I need the mass. Now I can use the formula that we all know from our previous knowledge of chemistry, that mass is equals to number of moles times molar mass, right? Times molar mass. Now if this is a standard formula, that means to get this mass, mind you, the number of moles has been gotten from the stoichiometric coefficient. The number of moles is simply what is standing in front of the element. Okay. Now for the glucose, you can see that the stoichiometric coefficient here is 1. Now for the biomass, you can see your stoichiometric coefficient is beta 3. And what do we get with beta 3 earlier? 4 over 4.4. So those are my number of moles. So the only thing left now is for me to get the molar mass. Now to get the molar mass, the mass of the biomass is number of moles, which is beta 3. Beta 3 is 4 over 4.4 times the molar mass. Now I have 12 times 1 plus, please do follow, molar mass I'm trying to calculate now is molar mass of this biomass. So I have 12 times 4.4 for the carbon plus 1 times 7.3 plus 14 times 0.86 molar mass. That you multiply each of the molar mass times the number of moles below. So this should be 4.4. Okay. So plus for the hydrogen, I have 1 times 7.3 plus for the nitrogen, I have 14 times 0.86 plus, and for the oxygen, I have 16 times 1.2. I'm explaining this because in some certain instances, you could be given an entirely different biomass. So as long as you understand what you're supposed to do, you won't have a problem. So this is the molar mass times the number of moles. Number of moles is stoichiometric coefficient, do not forget. So I have this over my mass of substrate. My substrate is glucose. Now the number of moles of glucose was 1 times, that's the stoichiometric coefficient of glucose in the equation was 1. I stated it here. So I have it times 12 times 16 plus 12 times 1 plus 6 times 16. So I have 12 times 6, plus, now this is for the glucose. I'm trying to find the molar mass of the glucose, plus 1 times 12, okay, plus 6 times 16. Now from this you can easily get your yield of mass of biomass per mass of substrate. Just input this into your calculator and get your final answer. Now for the last question, you have to calculate yield of biomass per oxygen. Now this is exactly the same thing like what we've done earlier. The only difference is that, now remember, your yield is mass of biomass per mass of substrate. I said the biomass is the product and the substrate is the reactant. Now let's look at this very carefully. I was asked to find mass of biomass per mass of oxygen. Now normally on a normal note, this oxygen here should be substrate. So if they are substituting it with oxygen, they are trying to say the oxygen in the reactant. Now I'm explaining this because it could come in any form. It could be YX nitrogen, it could be YX hydrogen, it could be anything. But depending on where it is placed. Now if you look at oxygen very carefully, in the reactant, where do I have oxygen? I have oxygen in the glucose and I also have oxygen in the beta one. Okay, now this glucose is the substrate, this is my oxygen. You have to be very careful. Now he said per oxygen. Now some people might get confused and just consider what I have here to be oxygen. Now this whole compound is your substrate, so you cannot like remove oxygen separately from this glucose. This is the oxygen we have to focus on. I also want to have a very deep understanding just in case you are giving in another form. Now this is the oxygen we are focusing on. This is no longer oxygen, this belongs to glucose. This is the oxygen we are focusing on, and because it's in the reactant side, that's why we are focusing on this aspect. If there was another oxygen on the product side, we will not mind that. We are focusing on this particular oxygen. Okay, so like we've done earlier, I have mass of biomass. Now from what we calculated earlier, you don't need to go through the whole process of calculating over and over again. You already got your mass of biomass here, so just simply insert it. So I have over mass of oxygen. Okay, now for the biomass, like I said, you've calculated that earlier. Whatever value you've imputed, you should get a correct answer because it's quite direct. It's just multiplication and addition. So after getting your mass of biomass here, the mass of oxygen, now I have number of moles of oxygen, which is beta 1. Okay, number of moles of oxygen is beta 1. That's what is standing in front of oxygen in the reactant site. Please do not mix these things up. Okay, so I have a number of moles of oxygen, beta 1, times mass of oxygen, which is 16 times 2. Okay, so do not forget you've gotten this one earlier from here. You've gotten the value of this earlier from here. You just insert it. Okay, now I have my final answer in mass of biomass per mass of oxygen. I'm calculating correctly. Thank you very much, and I hope you understood that. If you have any questions, do contact me.